So the chapter which I am going to start with is a refraction, okay, of light at plane surfaces. So in refraction, what we have seen, that is a bending of a light when a light travels from a one medium to the other medium, right? So if this is a rarer medium, this is a denser medium. So when a light ray travels from a rarer medium to the other denser medium, the light ray bend towards the normal. So if a light ray is traveling right now in this diagram, you are able to see the light ray is traveling from rarer to denser. This is the incident ray AO, right? OB is a refracted ray. This angle is called angle of incidence, this angle is called angle of refraction. The light ray will bend towards the normal when the light ray is traveling from rarer to denser. And in the other case, this is a normal point of incidence, refracting phase XY, AO, you can say, let us say this is rarer, this is denser, incident ray AO, this angle is called angle of incidence, so the light ray will bend away from the normal. This angle is called angle of refraction. Based on this, we have seen the laws of refraction of light. Incident ray, normal and refracted ray, they lie in a same plane. And second was the ratio of sine of angle of incidence to the sine of angle of refraction always remains constant, and that constant is called as refractive index, correct? So this refractive index depends on various factors. So right now, if you are able to see here that the ratio sin I to the sin R for a given pair of media, it means for a given air glass, for a given air oil, for a given air, any other air water, okay, so the ratio sin I to the sin R will remain constant, okay. Further, the symbol for refractive index which we had used is a mu. How it is mentioned mu to 1, it means that refractive index of second medium with respect to first medium. So it can be written as sin I upon sin R. Also, one thing we know that when a light ray travels from rarer medium to the denser medium, the velocity decreases, right? So if v1 is the velocity in rarer medium, v2 is a velocity in denser medium. So here in this case, v1 will be greater than v2. And what about in this case when a light ray travels from denser to rarer medium? So let us suppose here the velocity is v1, here the velocity is v2. In this case, same thing. Any doubt? Now in terms of formula, how we have, what is the formula we have? Refractive index of second medium with respect to first medium is velocity of light in first medium to the divided by velocity of light in second medium. Also we know that velocity is equal to frequency into wavelength. This is a relation which we have seen. Velocity is equal to frequency into wavelength, right? F for frequency, lambda for wavelength. Now one more thing in refraction of light, in phenomena of refraction of light, we know that when a light ray travels from rarer to denser medium, there is one quantity which remains unchanged. Which is that quantity? Frequency. So in refraction of light, the frequency remains constant. Please keep this thing in mind. It can be asked for multiple choice question. So if frequency is remaining constant, here the velocity is v1, here the velocity is v2, frequency here is f, frequency here it is f. So what should change? If velocity is changing, frequency is remaining constant, so will the wavelength change? Answer is yes. So here it should be lambda 1, here it should be lambda 2. So if I write the formula, I'll write here f lambda 1 divided by f lambda 2. So the formula will be lambda 1 upon lambda 2. Frequency will get cancelled. You have this formula as well. नहीं, formula याद होना चाहिए. Okay. Refractive index has any unit? No, because it is a ratio of two similar quantities. Ratio of two similar quantities. नहीं, ठीक है? Anything to discuss here? we'll move ahead now. अरे लिखना क्यों है अभी? हो गया now one phenomena which you need to remember, this is refracting phase xy, rarer medium, denser medium. If light ray is incident normally to the surface, it means angle of incidence is 0. So as per the formula, angle of refraction will also come out to be 0. So it means that the light ray will remain undeviated. Any doubt? Now the second point is principle of reversibility of light, very important, right? Formula is also very important. So let us suppose say again, rarer medium, denser medium, normal line, point of incidence, AO, incident ray, XY, refracting phase. The light ray will bend towards the normal. Agree? Now if I place a mirror over here, M indicates mirror. Now I have placed a mirror in such a way that the refracted ray, how it is falling on the surface? Perpendicularly. Now last year in grade 9th we have seen, if a light ray is incident normally to the plane surface, angle of incidence is 0. Angle of reflection is, because it's a mirror, there will be a reflection, angle of reflection will be 0. So the light ray will retrace its own path, that is it will rebound. So light ray will rebound and it will go in this manner, right? So if this is angle of incidence, this is angle of reflection. So when a light ray was traveling from rarer to denser, how you will write the formula for rarer to denser? Rarer to denser, mu 2 1 is equal to sin I upon sin R. Agree? Now when the light ray was traveling from denser to rarer, so the formula will be refractive index of first with respect to second will be equal to, here the R will change to I and I will change to R. Means as per the formula, angle of incidence here is R and here angle of refraction is basically I. Understood, Arush? If we take the example 30 degree 20 degree, so what I will write here, sin 30 upon sin 20, correct? Now when the light ray is traveling from denser to rarer, angle of incidence is 20, so I will write sin 20 upon sin 30. Understood? Now if I multiply these two equations, refractive index 2 into 1, refractive index 1 into 2, you will get sin I upon sin R into sin R upon sin I. This term will get cancelled. Ultimately you will get mu 2 1 into mu 1 2 is equal to 1. So ultimately last you got the formula, refractive index of second with respect to first is 1 upon refractive index of 1 with respect to 2. Get it out? Now this is a principle of reversibility of light. Why reversibility? Because the light ray has reversed its path. Okay, so we get this formula. Get it out here? Which one? Principle of reversibility, there is refractive index of first with respect to second with respect to first is 1 upon refractive index of first with respect to second. Means in short, if I have air medium with respect to glass medium, refractive index of glass with respect to air, this is first medium, this is second medium, air is rarer, glass is denser, refractive index of glass with respect to air is 1 upon refractive index of air with respect to glass. If question is asked for 1 mark, that refractive index, this was asked in prelims I guess, I don't know, somewhere, refractive index of glass with respect to air is, let us suppose, is 1.5. So what is the refractive index of air with respect to glass? So 1.5 is nothing but 3 by 2. So as per the formula, refractive index of air with respect to glass is 1 upon refractive index of glass with respect to air. So 1 upon 3 by 2. So 2 will go up. So 2 by 3. Solve this, you will get the answer. In it out. I think it's recurring 0.66. 0 na. Okay. Yes. Now glass slab. Refraction in a glass slab. Shall I erase this?
Yes.
Glass slab A, B, C, D. It's a glass slab. Okay. Let us suppose I have drawn a normal line over here. PO is a incident ray and O is a normal to the refracting face AB. You remember that glass slab? This angle is angle of incidence. Light ray, this is air medium, this is glass medium, so light ray will bend towards the normal. This is angle of refraction. If I draw the normal line over here, again if you see this normal and this normal, will it be parallel? So this angle and this angle should be equal. So now light ray is traveling from glass to again. So light ray will bend away from the normal. Correct? Now if we see the direction of incident ray, if glass would have been absent, then light ray would have traveled in a straight line if glass was absent. But since glass is present, the light ray has emerged out from this position. Let we give which name should I give? O dash. Chalega? Q. Any symbol it's okay. So PO is incident ray, O dash is a refracted ray, O dash Q is a emergent ray. So this angle we call it as a angle of emergence. And if you see, angle of incidence is always equal to angle of emergence, is always equal. Why? Because the direction of incident ray and the direction of emergent ray, they are parallel. They are parallel. Same. They are parallel. Okay. So angle of incidence is always equal to angle of emergence. Now, if we see here, the light ray was traveling in this direction, but it has emerged out in this direction. It means that the light ray has been displaced. So this displacement we call it as a lateral displacement. You can show it by small d. So this lateral displacement depends on angle of incidence. It depends on refractive index. It depends on thickness of the glass. Yes. Any doubt? Understood. So this is what you should understand from here. Nature of the medium. One more thing. One thing you should know, that refractive index is inversely proportional to wavelength. If you know this, then it will be easier for you to remember. Okay? Refractive index is inversely proportional to wavelength. Okay? Any doubt? So more the wavelength, less the refractive index, less the wavelength, more the refractive index. It doesn't mean that refractive index is changing. Does it mean refractive index is changing? Refractive index of glass slab will be constant, but for red color light will feel that the refractive index is less. in terms of blue light or violet light, the violet light or blue light will feel that refractive index is more. But if you ask, refractive index of glass never changes. You understood this fact? Very important. So this is done. I'll just take one question which was asked in board exam as well, and which was asked in during prelim. Some of you created a slight mistake. I remember. This is angle 1, refracted ray. This is angle 2. This is plane mirror. They mentioned it as to be plane mirror. This was air medium. This is liquid medium. Okay. What they have mentioned, that angle 1 is 45 degree. Angle 2 is 30 degree. Angle 1 is 45, angle 2 is 30 degree. First question, find the refractive index of liquid. So what I will do, I will use the Snell's law. Correct? Refractive index of second with respect to first is sin I upon sin R, sin 45 upon sin 30, sin 45 1 by root 2, sin 30 1 by 2, so 2 upon root 2. You can rationalize it. Those who don't know rationalization, I'll say multiply by root 2, divide by root 2. So root 2 into root 2, 2 get cancel, answer is root 2, and root 2 answer is 1.414. Okay. Now second question, show in the diagram the path of ray after it strikes the mirror and re-enters in the air. Mark in the diagram the angles wherever necessary. So if angle 2 is 30 degree, this is a plane mirror, so it will reflect in such a way that angle of incidence is equal to angle of reflection. Now again, if I draw this normal and this normal will be parallel. So that's why this angle and this angle should be same. So angle 2 is 30, so this should be 30. So this should be also 30. Now if I draw the normal line over here, again this normal and this normal is parallel. So ये वाला angle और ये वाला angle वापस same होगा. So 30 degree. So अगर ये 30 degree है तो ये कितना होना चाहिए? 30 डिग्री ये है तो ये 45 है, तो यहाँ पे भी 45 लिखो. That's it. Now the ray diagram is complete. Understood? वही तो. नहीं होगा ना बात. यहाँ पे अप्लाई करो, यहाँ पे एक फॉर्मूला अप्लाई करो, यहाँ पे एक फॉर्मूला अप्लाई करो, मल्टीप्लाई करो, अप्लाई होगा. हाँ होगा ना. Incidence and refraction same na. Incidence refraction same. Apply formula over here, multiply, you get the same. Good. Redraw the diagram. If plane mirror becomes a normal to the refracted ray inside the liquid, and state the principal use. Now what they are saying, that if plane mirror is placed normally, if the plane mirror is placed normally to the refracted ray will reflect in such a way that retrace its own path. That is what you are supposed to show. Understood? And state the principle used. What is the answer? Principle of reversibility of light. Any doubt? Okay. Now we'll go to the refraction through a glass prism. Shall I erase? Arush, understood? No, really, I'll say this. I'll try to upload today itself. Please do watch, okay? No, just for your revision. through glass prism. Okay. So in a glass prism there are two refracting faces and one, basically all three are refracting faces, but when we use a glass prism while performing the experiment, any of the two surfaces act as a refracting face and the other will act as a non-refracting, which is of no use right now. So we say it as a base. Correct. So A, B, C. Correct. Yes. So let us suppose this is incident ray. It is incident obliquely on refracting face AB. So this is a normal which is drawn. So this angle will be angle of incidence. Light ray is traveling from air to glass. Light ray will bend towards the normal. Towards the normal. This, so let us suppose P, Q is a incident ray. Q, R is a refracted ray. And now the light ray is traveling from glass to air. So let us draw the normal line over here. So light ray is traveling from glass to air. It will bend away from the normal. Correct? Now, if you see the incident ray, the light ray, if glass prism would have been absent, the light ray would have been traveling. Correct? Light ray would have traveled in this direction, but the light ray has emerged out in which direction? This direction. So RS is called as emergent ray. This angle is called angle of emergence. Okay. Now, what is angle of deviation? That is very important here. So this is the incident ray and this is emergent ray. So direction, the angle between incident ray and the emergent ray is called angle of deviation. Means लाइट रे ऐसे जा रही थी, है ना, लाइट रे इमर्ज कैसे हुई? यहां से. सो दिस इज डायरेक्शन ऑफ इंसिडेंट रे, एमर्जेंट रे. सो दिस एंगल इंसिडेंट रे, एमर्जेंट रे. तो ये जो एंगल बन रहा है दैट इज ए एंगल ऑफ डेविएशन. सो इन डायग्राम कहां से पता चलेगा, है ना? हम क्या करेंगे, एमर्जेंट रे को पीछे खींचेंगे. So it is intersecting at this point. So this angle is called angle of deviation. Any doubt? It is indicated by symbol delta. This is angle of deviation. Now one more thing to note over here, that delta is yes, more the wavelength, less the deviation, less the wavelength, more the deviation. So which color light will deviate more? If they ask you arrange in terms of ascending order or descending order, just like in radioactivity which we have seen, right? Red, हाँ. So lambda R, lambda Y, lambda V, arrange in terms of ascending order. Red color wavelength is more, so deviation will be less. Yellow color wavelength more than red but less than violet. So this will be the case. Delta R will be less than delta Y, will be less than delta V. So it means the deviation will be seen more in violet, most in violet. Okay. So the diagram which I have drawn here, the light ray which I have used here is a monochromatic light. What do you mean by monochromatic? Single color. Mono means single, chroma means color. Single color light. What if I allow a white light to pass through the prism? Why dispersion? Because just now we came to know, or anyhow you write, it means the same. Just now we came to know that different colors of light, the prism will behave differently for different color of light. Correct? White light में तो पूरा 7 कलर है ना, 7 colors are there in white light. So every color light will behave individually different, right? हर एक कलर को वो जो ग्लास प्रिज्म है उस 7 कलर्स को अलग अलग लगेगा. तो डेविएशन, रिफ्रैक्शन या फिर डेविएशन 7 कलर्स के लिए सेम होगा नहीं, अलग अलग होगा. तो इसका मतलब ये हुआ कि जब लाइट रे, वाइट लाइट प्रिज्म से गुजरेगी, पास होगी, तो 7 कलर्स क्या होंगे, स्प्लिट होंगे. They will split. The white light will split into 7 different colors. What is the reason? This is the reason. That's why you observe the dispersion of light. You understood why you observe the dispersion of light? Because of this. Any doubt? Okay. Now, if this is A, where A is angle of prism, right? Now, if we go individually for angle of deviation, right? So the light ray was traveling in this direction, but it has emerged in this direction. So this angle will be delta 1. Means this will be R1, this will be R2, this will be delta 1, this will be delta 2. So that is a total deviation. So delta is equal to delta 1 plus, we have one more relation, that is I plus E is equal to A plus delta. Right now derivation won't be asked, so I am not going to derive that. And yes, and A is equal to R1 plus. हाँ, क्वेश्चन में आता है, ठीक है. I have just quickly summarized all the prism. Yes, one more thing is left, that is graph, angle of deviation versus angle of incidence, right? So if we try to draw the graph of angle of deviation versus angle of incidence, right? What is found that initially, as we go on increasing the angle of incidence, here the angle of incidence is 0. As we go on increasing the angle of incidence, the angle of deviation goes on decreasing. There is one point where it becomes minimum. At particular angle of incidence, the angle of deviation becomes minimum. That minimum deviation is called angle of minimum deviation. And further, if we go on increasing angle of incidence, we find that the angle of deviation goes on increasing. We find that angle of deviation goes on increasing after this. So this point of this angle of incidence where the deviation is minimum, we find that angle of incidence is equal to angle of emergence. Not for all the angle of incidence is equal to angle of emergence. No. Yes, this is the only particular angle where angle of incidence is equal to angle of emergence. ये जब होता है तब deviation minimum होता है. तो ये फॉर्मूले कैसे चेंज होंगे? So I'll say at minimum deviation, I is equal to E. अगर एंगल ऑफ इंसिडेंस E के बराबर होगा तो R1 और R2 भी इक्वल होंगे. So R1 will be equal to R2 is equal to R, I will be equal to E. So how the formula will change? I plus E is equal to A plus delta. So let us write 2I is equal to A plus delta. So I, and one more thing, delta is equal to delta minimum. Delta is equal to delta minimum. So I'll write here I'll write minimum. So I is equal to A plus minimum deviation divided by 2. We have this formula. Plus. Okay. And what about this? What about this formula? A will be equal to, I wrote R1 is equal to R2 is equal to R. So R plus R. So A is equal to 2R. That is R is equal to A by 2. Okay. Any doubt?
R plus R वो आरटीओ रहता है ठीक है आर प्लस आर है वो आरटीआर नहीं है अच्छा यहाँ पे भी प्लस है वहाँ पे वो 80 टाइप का मेरे को सर देख ला भाई लिख लेता हूँ सर देखो वहाँ पे एक प्लस मिनिमम है या 80 मिनिमम
Okay, so there is one numerical we'll see. Okay, what is asked? What should be the angle of incidence? What should be the angle of incidence for a ray of light which suffers minimum deviation? Please listen to the question. What is the angle of incidence for which angle of deviation is minimum of 36 degree through equilateral prism? So each angle is 45 degree.
60 degree.
Oh, my mistake.
It's okay, sir.
60 degree. Correct? All three angles 180. 6 3 is 80. ठीक है? So angle of prism is 60 degree. Correct? So we are supposed to find out I. So do we have the formula for I? Just now I wrote the formula. I is equal to A plus delta minimum divided by 2. What is A? 60. What is delta minimum? 36 divided by 2. Answer is
96.
2 4 is 8, 2 8 is 16. So angle of incidence is 48 degree. Understood? I have explained you the formula just now, so you were able to explain. But in the exam, you should be able to recall the formula directly. Otherwise, you will play with that formula I plus E is equal to A plus delta. Okay? Make sure that you are able to recall it. अभी एक्सप्लेन किया ना मैंने. ठीक है? ठीक है. Now there is one application of refraction of light, that is real depth and apparent depth, right? Okay. Next concept is real depth and apparent depth. Correct? Real depth and apparent depth. What you observe, that if this is a coin which is placed at the bottom of the swimming pool or seabed, right? Mango. Right? So let us suppose this is a coin. Coin. Huh? It's a coin. You're not. No, I am not. Okay. So from this object, a number of light rays they come out, right? So let us assume the first light ray which is incident normally on the surface, so it will remain undeviated. Basically, this is a water and this is air, right? Second light ray, let us suppose incident at this point. This is refracting phase xy or surface of water. If I draw the normal line over here, the light ray is traveling from denser to rarer, so it will bend away from the normal. Correct? Now, this is one refracted ray. This is second refracted ray. They are converging or diverging? Diverging. Are they converging? So will the real image will form? They are diverging. So the diverging rays, how we find the image? We pull them back. Pull them back. So if I pull them back, where they are virtually intersecting, this is a point where if I pull this light ray backward, they will virtually intersect at this point. So that is a point where the image will be formed if we are looking from this side. Understood? Understood? So from here we'll be able to see where the coin is. Coin is here, but actually the real position is here. So if I say that small d is the real depth and x is the apparent depth,
And D minus X is the shift.
and d minus x is the shift in the position of the image. So shift can be calculated as
D minus X.
real depth minus
Apparent depth.
RD minus AD.
तो ये फॉर्मूला है RD माइनस
Ah,
Problem.
any doubt? This is angle of incidence I. So this will be also angle of incidence I. Correct?
Yes, correct.
We don't have that formula. Okay, ठीक है. That's it. I'll directly give you the formula now for relation refractive index of denser medium with respect to rarer medium is equal to real depth upon apparent depth, RD upon AD. And there is another formula for shift, that is shift is equal to real depth into 1 upon 1 minus 1 upon refractive index of denser with respect to rarer. Any doubt?
Sir, refractive index of denser medium with respect to rarer medium means the light ray of light starting from denser, right?
Denser to rarer. Light ray is traveling from denser to rarer. Okay, so why the pencil appears crooked? Second thing, if a fish is inside the pond and if is looking at the bird which is in the air medium, the bird will appear closer or away. Away. If there is a fish inside the water and the fish is looking at the bird which is flying in the sky in the air medium, the fish will think that the bird is far away. Farther away. Okay. And on the contrary, the bird will think that the fish is closer to the surface. Okay. That's it. Now, critical angle and total internal reflection. Shall I erase?
Yes, sir.
One of the important phenomena in ray optics. See why I have selected this question, because this is the only question where maximum 4 mark, 5 mark question is asked.
Post office time.
Yes. Yes, it can be asked. Refracting phase XY. Okay, I'll just draw it a little bit bigger. Refracting phase XY. Let us suppose this is a source of light, point source of light. The light rays emitted from this source of light will be infinite. Agree? The first light ray will be straight. It will remain undeviated. Angle of incidence I1. Angle of refraction R1. As I go on increasing angle of incidence, angle of refraction will go on increasing. There will be one position, there will be one angle of incidence where angle of refraction is 90 degree. That angle of incidence is called as critical angle. C. So how I will define critical angle? Critical angle is the angle of incidence for which
The angle of refraction in the rarer medium is 90 degrees.
understood. And still if I incident the light ray, so this angle of incidence is greater than critical angle, then the light ray will reflect inside the medium. This phenomena is called as total internal reflection. So for a total internal reflection to occur, There are two conditions. First condition is the light ray should travel from denser to rarer, and second condition is the angle of incidence should be greater than critical angle. So these are two main conditions for a total internal reflection to occur. Read out? Yes, we have formula as well between the critical angle and refractive index. So refractive index of denser medium with respect to rarer medium is equal to 1 upon sin c, or 1 upon sin c can be written as cosec c. Correct? Okay, fine. Yes, now we have different phenomena for the total internal reflection. The total internal reflection, this application of total internal reflection, we can use it to bend the light ray by 90 degree. We can use it to bend the light ray by 180 degree, right? So accordingly you can draw the diagram. These are the applications. Okay, so please go through those ray diagrams which are given in the textbook. We'll go with the one question, okay, that they ask normally to complete the ray diagram. Correct? For example, I'll go with this question. This is one of the board questions, right? We have solved point O 42 degree. This is from Selena book itself, from the exercise. It is one of the board question. Okay, what they have mentioned, critical angle is 42 degree. What is the critical angle of this glass? Critical angle of this glass is 42 degree. Okay, now what I will do, I will draw the normal line first over here at point of incidence. आरुष हमेशा याद रखो कि इंसिडेंट रे जब आप ड्रॉ करोगे तो जहां पे लाइट रे इंसिडेंट होगी वहां पे पहला नॉर्मल लाइन ड्रॉ करो. Where in which questions, where they are asking you to complete the ray diagram, a path of ray, light ray. तो मैंने क्या किया, यहाँ पे नॉर्मल लाइन ड्रॉ की. नॉर्मल लाइन यानी ये 90 होगा, तो अगर ये 42 है तो ये कितना होगा, 48 होगा. अगर आप क्रिटिकल एंगल देखोगे तो एंगल ऑफ इंसिडेंस क्या हुआ, ज्यादा हुआ, तो वो क्या होगा, रिफ्लेक्ट होगा. करेक्ट? तो ये भी कितना होगा, 48. तो अगर मैं यहाँ पे लाइन ड्रॉ करूंगा तो ये 48 है, तो ये भी, तो फिर से ग्रेटर देन क्रिटिकल एंगल, तो लाइट रे रिफ्लेक्ट होगी यहाँ पे, तो ये भी कितना होगा, 48. अब क्या करेंगे, यहाँ पे नॉर्मल लाइन ड्रॉ करेंगे. तो अगर आप देखोगे यहाँ पे 48 है, यहाँ पे 42 होगा, यहाँ पे 90, तो यहाँ पे होगा 48, तो ये होगा 42. अब एंगल ऑफ इंसिडेंस है, हाँ करेक्ट. अब एंगल ऑफ इंसिडेंस कितना हुआ, 42 डिग्री, विच इज इक्वल टू critical angle, so the light ray will pass along the surface. Understood?
Yes, sir.
There are some questions. हाँ देंगे ना. So that will be only 1 mark question then. करना कैसे है? Critical angle निकालो. Critical angle will be given in the question for the completion of path ray. We are talking about the numerical. Means real in practical life or in numerical. We have the formula ना, refractive index of denser with respect to rarer is 1 upon sin c. यहाँ से critical angle निकलेगा. अगर आपको refractive index पता है तो मान लो ये ग्लास है, ग्लास का रिफ्रैक्टिव इंडेक्स निकालना है आपको, तो इससे पता चलेगा. बेसिकली 42 डिग्री इज ए बेसिकली स्टैंडर्ड वैल्यू फॉर क्रिटिकल एंगल ऑफ ग्लास फॉर ए नॉर्मल ग्लास. ठीक है, तो यहाँ पे रिफ्रैक्शन एट ए प्लेन सरफेसेस खत्म होता है. हम आगे बढ़ते हैं रिफ्रैक्शन थ्रू लेंस के लिए. चला इरेज? अंडरस्टूड? Which phenomenon is observed over here? What is observed over here? What is observed over here?
Passing through.
A part of. ठीक है, टोटल इंटरनल रिफ्लेक्शन नहीं कहोगे आप, क्या कहोगे फिर? रिफ्रैक्शन। रिफ्रैक्शन हो रहा है ना, अंडरस्टूड?